A statistics instructor wants to know if the students were spending enough time doing the homework, and the instructor thinks it should be 48 hours. The collected sample shows all these numbers, some people more than 48, some people less than 48. But from this sample, the instructor wants to accept or reject this hypothesis that the students are spending less than the recommended amount of time. The instructor wants to show that the students are using less than the recommended amount of time doing the homework. All right, so you need to take 4 steps in hypothesis testing. The first step is to identify the null hypothesis and the alternate hypothesis. So because the instructor wants to show that the students are spending less time, this is what it wants to prove. The mean value of the average value of the time spent is less than 48. And for the null hypothesis, you can just always say mu equals to some value. The null value right here is 48, right? To show that it's not this, the default is that students are really spending the 48 hours. So this is the null hypothesis. And actually, it's not wrong if you put mu equal or greater than 48. But it's a matter of preference. Some books just have it always as equal for the null hypothesis. Anyways, because you're trying to show that something is less than a value, the rejection region is less than. So the tail is a one-sided, one tail on the left side because it's about less than. So we need to figure out this rejection region first. Okay, for us, the sample size, if you use the calculator to add all the numbers here and divide it by 12, you get 46. And indeed, it feels like that this sample shows that students are spending less than what's required. But, maybe this is close enough to 48 that it's not a good enough evidence to show that they're not spending 48 hours. So let's see. The sample statistic is this formula, x bar minus mu over sigma over square root of n, where x bar is always the sample mean, mu is always the population mean, so you have to know these letters, what they mean, and sigma is the population standard deviation. Oh, by the way, there is actually a very important point here. The population standard deviation is given to you, right? So despite that you only have 12 samples, which is less than 30, you still just use the normal distribution because the population standard deviation is given. Okay, if the population standard deviation is not known, and if your sample size is less than 30, then you have to use the t-distribution. So this will be called the t-score, and to use the t-distribution, you'll need to define something called degrees of freedom and all the other things. But this is just the normal distribution, so it's not that bad. Okay. So what you want to do is you want to compute the p-value, and the p-value is computed like this. See, the z-score is negative 1.1547, and the picture is like this. You have the standard normal distribution, and you have negative 1.15, and the significance of this sample that we have is the area on the left side, because it's a one-tailed test on the left side. So since our rejection region is on the left side, the p-value is computed as shaded area on the left side. So this will be using the p-value. We could have used the critical value, which would be to find the value of the boundary of the rejection region by using the inverse norm. but I just chose to compute the p-value. Okay, I think that's because the question was asking for the p-value first. All right, so we get the p-value by computing this, the area before negative 1.15, and that's by the calculator. You use the normal CDF. So let's go to vars. You go to normal CDF, enter, and you put the upper as negative 1.1547, enter, and that gives you 0.1241. And because this is bigger than your significance level, that means we cannot reject H0. And that's different than saying that H0 is true. It's just that we cannot reject the hypothesis that students are really spending 48 hours. It's a different thing to say that, oh yeah, students are really spending 48 hours than to say that, we do not know whether or not students are really spending 40 hours, but there's no evidence against that, okay? All right, so that's our conclusion, and with 0.08 significance level. So that's our conclusion with this p-value. Now let me explain a little bit about the critical value approach. So for the critical value approach, the z critical value is the region where the area is same as the given significance value, right? So what you need to do is you have to do second vars, and you use inverse norm, and then put the area as 0.08. That's our significance area. And if you put that, you get negative 1.4051. So as you can see, the critical region, the rejection region, which is bounded by the critical value, ends at negative 1.4051. So even if you use the critical value approach, you still get the same conclusion. They should always give you the same conclusion. The negative 1.1547 is in the white area, not the rejection region, because it's in the right side of the critical value. So we know that we cannot reject H0. And additionally, some questions ask you to write down the rejection region as an interval. As an interval, the rejection region is everything on the left side of negative 1.4051. So you start from here and you go to negative infinity. So it's negative infinity to this part. When you write an interval notation, always the smaller number goes first. And since negative infinity is smaller than any other number, it's negative infinity to negative 1.4051. That's the rejection region. Okay.